So hooray, we come to the geostrophic balance that I already mentioned on the second slide of this lecture, the geostrophic balance. Okay. It's a relatively simple balance. Okay. So how it starts is it starts with a horizontal pressure gradient force. And I show you on the next slide how actually does a horizontal pressure gradient force looks like, and what creates these horizontal pressure gradients. However, over time, on time scales of a day or longer, this horizontal pressure gradient force becomes balanced by the Coriolis force. And there is a balance, and we call it geostrophy or the geostrophic balance. And now the fascinating bit, and I just mentioned this, is that you can actually derive geostrophic flows in the ocean from temperature and salinity measurements. Okay. Plus you need some information on the shape of the sea surface, or you assume a certain level of no motion. Okay, and this is just for me to mention. It is fascinating because if your neighbor comes and asks you about this, how can you derive currents in the open ocean, and you say you measure temperature and salinity, they think you're crazy. Okay, but anyway, so this is known, if you want to look it up, it's known as the geostrophic method. All right, the geostrophic balance, and bringing it back to the oceans, this controls the flows in most parts of the ocean, except for close to the surface and close to the seafloor. Okay, so everything that you get on longer time scales is influenced, or is controlled by the geostrophic balance.